Joining me in the studio today to enlighten us on the latest and greatest on everything in astronomy and science is Dr. Fred Watson, the head astronomer at the Australian Astronomical Observatory, author of the recently released book titled Stark Raving Mad, and one of the most interesting people I've ever spoken to. Dr. Watson, thank you so much for your time this morning and welcome.
Thanks very much, Victor. It's a great pleasure. And, well, you must have spoken to some boring people.
Not at all, not at all. Dr. Watson, if I may, I'd like to jump straight in. Researchers in the United States have cautiously reported they have detected the first physical evidence of dark matter. Firstly, what is dark matter, and I guess what are the implications of the team potentially confirming its existence?
Yeah, so dark matter is something that has been discovered by astronomers, although the emphasis has now shifted to subatomic physicists. But the discovery, in fact, it goes back to the 1930s. It was first noticed back in 1933 that there seemed to be something that had gravity that was affecting clusters of galaxies, actually, but was invisible. And then during the 1970s, people realized that galaxies, which are huge aggregations of stars and gas and dust, one of which we live in, a thing called the Milky Way galaxy. The Sun's one of 400 billion member stars of that galaxy. These galaxies were rotating too fast to hold themselves together if there was nothing more there than what you could see. And the inference of that was that there's something which has been called dark matter, which is holding them together. Now, what's happened over the years is that this has become a big quest for astronomers to try and work out what this stuff is, and it's basically been narrowed down to some kind of subatomic particle which essentially infuses the universe, and critically it likes to be where normal matter is. But also critically, it outweighs normal matter by 5 to 1. So for every kilogram of normal matter in the universe, there's 5 kilograms of this invisible stuff which we can't see. So, as I said, the focus has now shifted to looking at the subatomic world, and there are a number of experiments which are going forward to try and reveal that.
And we wait with bated breath for the results of those experiments. Back on dark matter for one more question. The Big Bang Theory predicts the existence of dark matter. Am I right in saying that? And secondly, does dark matter not cancel out actual matter, for want of a better word, when in fact they come into contact with each other? And is this one of the reasons why it's been such a hard particle to pin down physically? Hopefully I'm on the right track here.
Yeah, to some extent. Certainly the existence of dark matter is something that is predicted by the Big Bang Theory. But dark matter and normal matter can exist together, and this is actually one of the really tricky things about dark matter. If you imagine these subatomic particles, I mean, we ourselves are made of subatomic particles, and that's what we call normal matter, the stuff that we're made of. But coexisting with that is this other stuff which is more massive and which doesn't actually interact with normal matter at all except through gravity. So this is, one of the suggestions for these dark matter particles is that they will pass right through the Earth without noticing anything because they don't interact with normal matter. And that's why it's so difficult to detect them, because all the experiments that you can do with subatomic particles rely on particles that do somehow interact either by forming light particles or by deflecting particles. Those are all the kind of things that you look for when you're trying to identify subatomic particles. But these dark matter particles don't do that. The only way they interact is through gravity. And gravity is a phenomenon that occurs on large scales. That's why it took astronomers to notice that there was something there and that this didn't come actually from the world of particle physics.
I guess we'll have to wait and see what this potential discovery brings to the world of science and technology. Now, I understand you have some exciting news on a discovery made by the Kepler Telescope.
Yeah, that's right. Going to things that are probably easier to get your head around. And I guess what we're talking about here, Victor, the big thrusts in astronomy at the moment are, one, to understand what dark matter is, and something else equally mysterious but quite unrelated called dark energy, which I'm sure we'll talk about sometime. But the other quest is really the search for habitable planets, places in the universe where life might have originated, as it did here on Earth 3 billion or so years ago. And one of the main tools in doing that is to investigate the stars in the neighborhood of the sun, and by fairly careful observation to work out whether they have planets going around them. Now, actually, you've only to look back 18 years to see a time when we didn't know that other stars had planets going around them. We guessed they probably would do, but it was actually in 1995 when the first observation was made that revealed another planet, a planet going around another star. Since then, we've had a whole lot of experiments, one of which is a spacecraft called Kepler, named after the great 17th century German mathematician Johannes Kepler. And what Kepler does is it looks at stars round about 100,000 at a time and measures the brightness of those stars very accurately and in a repeated fashion. And the idea is that if there's a planet going around one of those stars, then its light, as the planet passes in front of the star, it will dim the light of the star slightly. And so you see a signal in the intensity of the star. Its light is slightly dimmed, and you can assume that that's because a planet's passing in front of it. Now, Kepler has been very successful. It's got something like 2,000 candidate planets in its inventory, and some of them, these planets, are very interesting. And one of the stars rejoices in the magical name of Kepler 62, and that is known to have 5 planets going around it, 2 of which are of interest because they may be Earth-like, they may be habitable planets. So that's why that story is in the news at the moment. It may well be that we found somewhere in the universe where life could exist.
And I understand these planets fall in what's termed as the Goldilocks zone, the zone surrounding the sun that is perfect for, I guess, life as we know it.
Yeah, that's right. It's actually the Goldilocks zone of a star. It's defined as the region around the star where it's not too hot and it's not too cold, but it's just right for liquid water to exist. That's why it's called the Goldilocks zone. And so it's all about the ability of a planet to have liquid water on its surface, which we believe is very important for the evolution of life. We know that life on Earth evolved in water. So even though there may be forms of life that don't need water to evolve, at the moment, all we can do is take the example of the Earth and say, well, if there's water out there on a planet, maybe life will have kick-started on that planet too. And that's why these places are of great interest.
Now, moving along, I believe a new type of rocket was recently launched to carry cargo to the International Space Station.
Yeah, that's right. The way the space age is moving these days, Victor, is very much that the commercial sector is taking over the reins. You probably know that 3 years ago, NASA wound up the Space Shuttle program, and a lot of people thought that NASA had lost interest in space, and in particular in human space flight. But actually that wasn't the case, because what NASA has done is essentially concentrated on all the really high-tech stuff that needs really cutting-edge technology to develop it, and devolved the more humdrum work, if you can call it that, of getting supplies up and down to the International Space Station. They've devolved that to the commercial sector. So there are 2 major companies which are involved with this. One is called SpaceX, and they made history last year by flying the first unmanned cargo ship to dock with the International Space Station. Their Dragon capsule back in May last year, in fact, successfully took cargo up to the space station. The other company is Orbital Sciences. They are a little bit behind in the, not exactly a race, but in the timeline to supply the International Space Station. Their contract has not quite fully kicked in from NASA, but they had a big triumph at mid-April when they successfully launched their Antares rocket and managed to put a small payload, actually it's not that small, it was nearly 4 tons, into orbit. It wasn't a permanent orbit, it will burn up in the atmosphere in a couple of weeks or so, but that demonstrated that the Antares rocket has the capability to supply the International Space Station. So this is all really good news, and I think NASA are delighted that the 2 companies that they've backed to act as the kind of taxi service down the track for astronauts, that's not happening yet, but will do. I think they're delighted that these companies are both succeeding very well.
I'm sure you've heard of Virgin Galactic, the Richard Branson-backed company who is at the moment trying to develop a spacecraft that can be reused for commercial space travel. Was this part of the NASA strategy to get private business involved in, for want of a better word, space tourism?
This has developed quite separately because the Branson exercise, Virgin Galactic, actually has its origins almost a decade ago when a company called Scaled Composites, which is a company that makes plastics actually, developed a rocket plane that successfully won something called the X Prize. And the X Prize was a prize given to a rocket plane, the manufacturers and operators of a rocket plane that could fly up to 100 kilometers with a human passenger and do it twice within a fortnight. The idea being to show that that would be something that could be repeated. Now, that historic flight, which was in 2004, really set the way for Branson's Virgin Galactic exercise, which is developing a space plane very similar to the one. By the way, it had a really imaginative name. It was called Spaceship One. So I think the names have changed a little bit since then. But Virgin Galactic is expecting to fly paying passengers. Well, they say within a year, but it's been within a year for some time now, and I can understand the caution with which they're proceeding, because this is the kind of thing that you've really got to get right. If you're getting people, 4 passengers or 6 passengers into a rocket plane and sending them up to 100 kilometers, the last thing you want is an accident. So that is progressing well. Branson has a huge waiting list of people waiting to fly. They won't go into orbit. This is something called suborbital tourism. You basically go up, experience 3 minutes or so of weightlessness, and then come back down to Earth. But nevertheless, it's an experience of space, and one that at $200,000 a pop is not really affordable to most of us, but is affordable to some. So it will succeed.
Absolutely, and I guess it is a stepping stone along the way to full-blown space tourism. But Mr. Watson, Dr. Watson, sorry, thank you so much for your time today. It has been enlightening as always, and I do look forward to our next chat.
Thanks very much, Victor. Great to talk to you.